In the previous video, we learned how to set up the initial simplex tableau. In this video, we'll proceed to working with the initial tableau, using row operations, and see how that can lead us to a solution of linear programming problems with the simplex method. The kind of problems we're going to be considering for starters are what are called standard problems. In a standard problem, first off, it's a maximization problem. Secondly, it's a problem where the variables are restricted to non-negative values, which has been the case in virtually every problem we've seen. And thirdly, the constraint inequalities are of less than or equal to type with a positive constant on the right. The problem of the potter and the clay is a standard problem. We're maximizing our profit, so it satisfies condition 1. The variables are constrained to non-negative values. That's what these two conditions say. And finally, the constraints are less than or equal type constraints with a non-negative number on the right-hand side. So this is a standard problem. The equations that form the initial simplex tableau in this problem, we take the constraints and introduce slack variables. We rewrite our profit function in the form shown here with everything on the left. So this is what goes into the initial simplex tableau. And the initial simplex tableau is the one shown here, the setup being the same as the methods illustrated in the last movie. I'm going to convert the decimals to fractions. That's primarily a matter of preference. You wouldn't have to. So the 0.75x coefficient I'm putting in as a 3/4, and the minus 1.5y coefficient in the bottom row I'm putting in as minus 3/2. But I have come to this initial simplex tableau using exactly the same mode of analysis that we demonstrated in the last video. So the question, of course, is what do I do with this initial tableau? Once I have my initial simplex tableau, what do I do with it? The first thing we do is look for the most negative number in the bottom row, the most negative number to the left of the line. In other words, I don't pay any attention to the bottom right hand corner. We'll not have a negative number down there, but we're never going to be basing our decision of what to do according to what's down there. So the spots I'm looking at are these bottom row entries other than that one. The most negative number that I see there is the minus 2. Now that's not my, I'm choosing what we call a pivot element. That's not my pivot element, but it determines which column my pivot element is going to come from. In fact, our pivot element will never be in that bottom row. It'll be one of the numbers above that that entry, which means I'm going to be picking my pivot element from the first column. The way we determine who wins the contest to be the pivot element is to take each of the other numbers in that first column and divide them into the corresponding number at the far right of their row. So the 3/4 gets divided into 250, which comes out to 333 1/3, and the 6 gets divided into 1200, which comes out to be 200. So we're looking at these two ratios, 333 1/3 and 200. And the winner of the contest for who gets to be the pivot element is determined by which of those is the smallest ratio. In this case, 200 is smaller than 333 1/3. And the fact that 6 into 1200 gives us that smaller ratio means that the number 6 wins the contest to be the pivot element. Now what we're going to do with that pivot element is very reminiscent of the row operations that we did in part 1 of the course when we were solving systems of equations or finding the inverse of a matrix. That is, we're going to use the row operations to turn that 6 into a 1 and turn the other numbers in that column into zeros. So how will that work? To turn the 6 into a 1, we'll multiply row 2 times 1/6. So that will make the 6 a 1, the 3 a 1/2, the 1 a 1/6, the 1200 a 200. So it's just like being back in our study of matrices. So we've accomplished that, and now we want to turn these other two entries into zeros, and we pick our row operations to do that in exactly the same way we did back when we were talking about matrices. To turn the 3/4 into a 0, we will do row 1 minus 3/4 row 2, so we'll be doing 3/4 minus 3/4, and we'll change the minus 2 into a 0 by doing row 3 plus 2 row 2, so we'll be doing minus 2 plus 2. So when you carry out the operation row 1 minus 3/4 row 2, we get the new row 1 shown here. And when we carry out this row operation to get the new row 3, we get the row 3 shown here. And we have now finished the first step. We have found our first pivot element, turned it into a 1, and the other entries in that column into zeros. That first step may not necessarily involve the first column. It could be any other column, depending on how our process for finding the first pivot element had worked out. In this instance, it happens to be that the first pivot column is the first column of the matrix. So anyway, we have finished the first step. So where are we now? One thing that's worth doing is to stop and play this little game. Anytime you have just finished a step, a complete step, while you're working in the simplex method, you can give an interpretation to where you are at that point in the solution process. Here's the way you play that game. You locate see, some of the columns are in a special form. They have a 1, and then the other numbers in the column are zeros. You can see the X column is in that form, the U column is in that form, and the P column is in that form. These are the columns where there's a 1 and all the other entries are 0. There are also two columns that are not in that form. I've X'd those out. The game we're going to play right here is to take those variables, the Y variable and the V variable, whose columns are not in that special form, and set those guys equal to 0. So I'm going to set Y equal to 0 and V equals 0 because their columns are not in that special form. And then I'm going to simply cover up those two columns. So in your mind's eye, cover up the Y column, cover up the V column, pretend those columns aren't even there, and think about what equation would be represented by each of the rows of the matrix. If you mentally wipe out the Y column and the V column, then the first row would say 1 times U is equal to 100. The second row would say 1 times X is equal to 200. And the third row would say 1 times P is equal to 400. So we would have these three values. So what this first step of the simplex method corresponds to is taking us to a point in the solution region where the value of X is 200, the value of the profit is 400, and the value of the slack variable U is 100. The other slack variables have value 0. I want to go back and point out that you can play this game even with the initial simplex tableau. We could have done this even before we started the solution process. If you go back and look at the initial tableau, the columns which are not in the special form of having a 1 and the other number 0 are the X column and the Y column. So if you play that game we just played of setting those variables equal to 0, X equals 0, Y equals 0, block out those columns and read what equations would be represented by each of the rows. If you block out the X and Y column, then the first row would say 1 times U is 250. 1 times V is 1200, and 1 times P is 0. So that corresponds to x equals 0, y equals 0, and profit being 0, which if you think about a geometric picture of the solution process simply says you're at the origin. So what we'll find is that each step of the process, when we're applying the simplex method, takes us to a corner point of the solution region. It does it algebraically. We don't have to do any graphing, but logically that's what it's doing. And in fact, even the initial simplex tableau is starting us out at one of the corner points of the solution region. Specifically, it always starts us out at the origin. So you can think of the initial simplex tableau as always corresponding to the corner point, which is the origin. In a standard problem, the origin is always a corner point of the solution region. Now let's go back to where we were left off after we had completed the first step of the process. This is what our tableau looked like after the first step. So now we simply play the game again of choosing another pivot element and carrying out another step. Remember, the first step in choosing a pivot element is to grab the most negative number from this portion of the bottom row. Ignore what's in this bottom right-hand corner. Pick the most negative number from this portion of the bottom row. And of course, now we have only one negative number in that area, which is the minus 1/2. So it automatically wins the contest of having its column be the column from which the next pivot element comes from. Remember, the pivot element never is from this bottom row, but since this is the most negative number in the bottom row, the pivot element is going to come from this column, and that means column 2. So there are two candidates for pivot element. There's the 5/8 and the 1/2. So we have to play the ratio game again to find out which of them wins the contest to be the next pivot element. The ratios we check are 5/8 into 100, which is 160, and 1/2 into 200, which is 400. Of those two ratios, 160 is the smaller of the two, which is why 5/8 wins the contest to be the next pivot element. So for this next step, what we're going to do is use row operations to turn that 5/8 into a 1, and these other two numbers in the second column into zeros. The first of those row operations will be to multiply row 1 times 8/5. That will make the 5/8 a 1. That brings us to this point. We have the 5/8 turned into a 1. We need to turn the other two numbers in the column 2 into zeros. So think about what the row operations would be that would accomplish that. We'll use R2 minus 1/2 R1 to make this guy a 0, and we'll use R3 plus 1/2 R1 to make this guy a 0. So carrying out these two row operations bring us to this tableau right here. So we've completed our second complete step of the solution process. At this point we're done, and the reason we're done is because there are no more negative numbers in the bottom row. Remember, each step began by looking in this portion of the bottom row and grabbing the most negative number. We've reached a point where there are no more negative numbers down there. That's the key that we have finished, and we have found the optimal solution. So we simply need to interpret what that solution is. Which columns are not in the special form of having a 1 and the rest of the number 0? They're the U column and the V column, right? So we set those variables equal to 0. And then we block out those columns and interpret each row as an equation and see what it says. The first row, if you block out the U and V column, the first row simply says y is equal to 160. The second row says x, 1 times x, is equal to 120. And the third row would say that 1 times p is equal to 480. So that's our optimal solution. The maximum value for p attainable is 480. and you get that value when x is 120 or when y is 160, and each of the slack variables is equal to 0. This is the same solution that we arrived at when we earlier did this problem geometrically. We've now done it algebraically using matrices. We haven't done any graphing, but we've arrived at the same solution that you do arrive at when you do this problem using the geometric method that we studied in part 2 of the course. Let's look at one further example in this video. Let's think about maximizing p equals 3x plus 4y subject to the constraints shown here. Now I'm going to make you do some of the work here by deliberately leaving out some of the steps. Your initial simplex tableau for this example will look like the augmented matrix shown down here. So to arrive at that, what will you need to do? You'll need to introduce your slack variables in these two constraints. You'll need to rewrite your profit function, putting it on the bottom. And then that will give you the three equations that lead to the augmented matrix here. So fill in that step. Fill in those steps. Fill in the process of doing those things and labeling your columns appropriately. Now, where will you go from there? This is your initial simplex tableau. What will be the first step of your simplex method solution? Grab the most negative number in the bottom row, which is the -4, right? So that determines that your first pivot element will come from this column. It will be one of these two numbers, won't it? Go through the process of checking the smallest ratios to determine which of these two numbers becomes the first pivot element, and you should find out that it's the 3. So make sure you understand why 3 becomes the first pivot element. Once you have thought through that, pick your row operation that will make that 3 a 1. Once you actually do that row operation, this is what your new second row should look like. So make sure you understand which row operation is done to produce this new second row. The remaining part of that first step will be to turn this guy and this guy into zeros. Write down your row operations that perform those two steps. When you carry out those two row operations, you should arrive at this matrix right here. So this marks the end of the first step. We have found our first pivot element, we have made it into a 1, and we have made the other entries in that column into zeros. We've completed one step in the solution process. We know that we're not done because we still have a negative number down here that we have to take care of. So our second step begins by picking the pivot element from the column associated with the -3, which is the first column. Now here we run into something new, which I probably should have mentioned earlier, although this is fine for it. When it comes to checking ratios, we can divide the 1 into 2. You can't divide 0 into 3. You don't divide by zeros. So what I should have said when we were checking ratios is that the pivot element, while we're talking about standard problems, always has to be a positive number. The pivot element has to be a positive number, so 0 isn't even a candidate to be the pivot element. So we don't have to worry about the fact that we can't divide by 3 by 0. 0 can't be a pivot element because it's not a positive number. So there's only one candidate for the pivot element in column 1. It's the 1 that's there, and so 1 wins by default the contest to be the next pivot element. The remaining thing we have to do in this second step is to turn these other entries into zeros. One of them is already a 0. Make sure you understand the row operation that's performed to turn the minus 3 into a 0. When you carry out that row operation, this is what you should get as your new third row. And at this stage, you know that you're finished with the simplex method process because you no longer have any negative numbers in this part of the bottom row. You should have labeled your columns as shown here. You have finished the simplex method process. Go through the steps of writing down the interpretation of your solution. Make sure you understand the thought processes whereby you go from this final simplex tableau to the solution x equals 2, y equals 3, and p equals 18, with both of the slack variables being equal to 0. So just to describe verbally what the solution of our problem is, we would say that the maximum value of p is p equals 18, and that that value is attained when x is 2 and y is 3. So that's the solution of the problem we would have arrived at if we had done the problem geometrically. We didn't have slack variables, of course, when we were talking about the geometric solution, but with regard to the slack variables that we introduced, we do pick up the additional information that their value is 0 here. So make sure you understand how to go from this tableau to this chunk of information. And if you do, then that tracks us through the complete solution of this example using the simplex method.